Hi all. Let's see frequent pattern growth algorithm today. We'll see a problem. So in frequent pattern, the main advantage is to overcome the disadvantage of a priori algorithm. So the main thing is in a priori algorithm, it may need to generate a huge number of candidate sets. We are generating C1, C2, C3. Like this, for each and every candidate, we are scanning the database more time. So there is a main disadvantage in a priori algorithm, and it may need to repeatedly scan the database and check a large set of candidates by pattern matching. So under each candidate key generation C1, C2, C3, C4, every time we are scanning the databases multiple times. So this makes the time consuming. Thus, to overcome this disadvantage, we are going for the FP growth algorithm where we are not scanning the database as much as the candidate key we are generating. Let us get into the problem. So this is the problem. So we have 9 transactions here. The first transaction is T100, which is having a list of items I1, I2, I5. T200, which is having a list of item I2, I4. Likewise, we are having till T900. So when you just check the occurrences of each and every item, we have 5 items here: I1, I2, I3, I4, and I5. So the occurrences of I1 is we'll have 6. See here, you have 1, 2, 3, 4, 5, 6. So the occurrences of I1 is 6 here. Then the occurrences of I2, 1, 2, 3, 4, 5, 6, 7. So occurrences of I2 is 7. I3 is 1, 2, 3, 4, 5, 6. So we have 6 here. Then I4 you have 1, 2, that's all, 2. I4 is 2 here. And then I5 you have 1, 2. So you have 2 here. So these are all the occurrences of each and every item. So here when you arrange this in descending order, so I2 is the largest, then I1 and I3 have 6. So I have put it in I1 is coming first, I1 6, I3 6, I4 2, and then I5 2. So this is the descending order of the key, that is list of items. So according to this order, I'm going to arrange my transactions, list of item in every transaction. So when you come to T100, I'm arranging T2 is having the highest, T1 the next highest, that is I1 the next highest, then I5 the next highest. When you come to T200, you have I2, I4, where I2 is the first highest and I4 is the first highest. So I'm putting as such. When you come to T300, I2 is the first highest, then I3. So I'm putting as such. When you come to T400, where I1, I2, I4, you have I2 as the first highest, so I2, and then you have I1, I have put I1, then I have I4, which is 2. So it will be 7, 6, and 2. So I2, I1, I4. Likewise, I have arranged everything from T100 to T900. I have arranged everything according to the descending order occurrences, the highest occurrences of items. So now I have put this table here because now we are going to draw the FP growth tree. So now let's see how we are going to draw the FP growth tree with the number of occurrences. So now let's see, the root node will be always the null. The root node will be always null. So what happens? Will be always null. So now let us take the first transaction. So the first transaction, I2, I1, I5. So what happens? I'm putting I2 here and then I1. From I1, I2, I'm putting I1. Then from I1, I'm extending to I5. Now the occurrences of 1 for I2, occurrences of I1 is also 1. Then the occurrences of I5 is also 1. Now let me take the next transaction, which is I2 and I4. So I2 I have already 1, so I'm adding it up 1 again, and then I4. From I2 here it's already we have I1, I5, but now it is I2, I4. So from I2 I'm drawing a I1. So the occurrences here is 1. Now T3 transaction, that is T300, I2 and I3. I2 already I have, I'm adding it up once again here, and then from I2 I'm adding a I3 here, which is 1. Then what happens? The fourth transaction T400, I2, I1, I4. So I2, Now I'm going to have one transaction here, then I have I1 here, and then from I1 I have only I5 earlier. Now I have to draw the I4. So from I1 I'm drawing the I1, sorry, I4. From I1 I'm drawing the I4, which is 1. So now till T400 it is over. So now it's T500 from I1, I3. So it's starting from I2 here. So what I'm doing is I'm drawing another branch where I have I1. So first I1 here, and from I1 I'm having a I3 here. So see here, I1, I3 is completed now. So now I have next transaction I2, I3. So I have I2 already. So I'm adding it up 1. And then from I2, do I have I3? Yes. So I'm adding it up one more here. Now what happens? This is also completed. Now let me come to T700 from I1, I3. I have already I1 from the root. So I'm adding it up 1. From I1, I have an I3 already. So I'm adding up 1 here. And the next one is I2, I1, I3, I5. So I have I2, I have I1, I have I3 already, right? No, I don't have I3 already. So I'm making a new extension here I3, and then from I3 I'm making a new extension I5. So when you come here, you have a I2 here. I'm making it as one add up. From I2 you have I1. Okay, I'm adding it up. From I1 there is no any transaction called I3 earlier, so I'm making one transaction here, which is I3. Then from I3 it is I5. I'm making one transaction here. Then T900 you have I2, I1, I3. So let me check I2, I1, I3. Just now we draw this. So we are having I2, I1, and then I3. Now all the transactions we have completed. Fine. So now we have drawn the FP growth tree also. Now if we consider, if we count all those add-ups, see here 1, 2, 3, 4, 5, 6, 7. So totally 7 I2 we have covered. So as per our occurrences of items. So I2 7 times it have occurred. Yes, 7 times it had occurred. When you come to I4, 1, 2, 3, 4, 4 times. So 4. Okay, so is there any other I4 we have here? Yes, I have one I4 here. So what happens? 1. So it means that I4, how many times it had occurred? It had occurred 4 times. Sorry, we are seeing I1, right? So I1, where I1? Yeah, so I1 you have it here. So 2 times it had occurred. So 1, 2, 3, 4, and this is 2 times. So I1 is 6 times. So yes, 6 is also now satisfied. Now let's go for I3. So now you have a I3 here, which is 2. Okay, 2 times it had occurred. So 2 times it had occurred. And then any I3 we have, yes, here also 2 times it had occurred. So 2 I3 where 2 times it had occurred. And also we have a I3 here where 2 times it had occurred. So 2 plus 2 plus 2 where 6 times it had occurred. I3 had occurred 6 times. So I3 is 6. Now if you go to I4, so here we have I4 for 1 time, and then we have I4 for 1 time. So I4 is 2. 2 occurrences of I4 have also occurred in the tree. Then if you come to I5, 1 time it had occurred. Then here also 1 time it had occurred. So 2. So I5 is also 2. So now this tree had satisfied all the components list of items occurrence. So as per our calculation, the same calculation is coming in our FP tree. So it means that all the items had occurred properly in the FP tree. We have drawn the FP tree properly. So what is this? I2 is to 7, I1 is to 4. These are all the support counts. So here how many times for this node, how many times it have occurred? That is why I've put this line. So 7 times it occurred. So I2 is to 7, which is the support count for I2 for this node. Now you can see I1 it had occurred 4 times here. So the support count is I1 is to 4 for this node. And then for I5, you can say that it had occurred 1 time in this node. And when you come to I3, in this node, I3 had occurred twice. And in this node, I4 had occurred once. So I4 is to 1. And here I5 have occurred once. and then I4 had occurred 1. So everything this is to 1 is to 2 is everything is the support count of the occurrences of those items at that node. Then what's happening is I'm just linking the node to each and every node, corresponding node. So I2 I'm just linking here. So I'm just linking here I2, and then all those 7 I have here. Then if I come to I1, so I'm linking to I1 here, and then do I have I1 anywhere else? Yes, I have one here. So from there I'm linking here. Okay. Then from I3 I'm going here. So I3 I'm linking to this. Then do I have any other I3? Yes, I have this I3. Do I have any other I3? Yes, I have this I3. All the I3 are connected together. And then when you have I4, let us see I4, where do I have? I have I4 here. So I'm connecting I4 here. Then do I have I4 anywhere? Yes, I have I4 here. So I've connected all the I4s. And when you come to I5, I have an I5 here. From this, I have a I5 here. Is there any other I5? No. So like this, I have connected with the node links also. Now let us see the minimum frequent item sets without candidate key generation. I have also given this tree here for the reference while we are generating the frequent patterns. So when you come here, I have put all the items I5, I4, I3, I1. I have not put the I2 because for all these items, we are going to go through, or we are going to navigate the paths, in which path it had traveled. I5 means it had traveled from I2, I1 to I5. Then anything, then it have traveled from I2, I1, I3 to I5. So like that, I'm going to navigate. Whereas I2, we don't have anything to navigate. We have only the root node null. We don't have anything to navigate. So I'm eliminating this I2. The remaining all nodes I have put I5, I4, I3 and I1. So now what happens in the descending order according to the items I have put it I5, I4, I3, I1. Now let me generate the conditional pattern base. What is conditional pattern base? Now I'm going to see what are all the paths each and every item have navigated. When you come to I5, so this is one path, I2, I1, I2, I1, this is the one path, okay? I2, I1 is this path, so I2, I1. What is this one support count? This one support count is, what is the support count? We'll have it for I5. So to reach this I5, it is navigating through I2, I1 with the support count 1. That is I5 is 1. So I2, I1 with the support count 1. Then the another I5 is here. So it is navigating from I2, I1, I3 with the support count of I5 1. So I2, I1, I3, which is I2, I1 and I3 with the support count of I5, which is 1. When you come to I4, so now we are going to find the conditional pattern base, how it's navigating to I4. So I4, this is one I4. So it is navigating through I2, I1 to I4, I2, I1 to I4. So the support count for I4 is 1. So I2, I1 is to 1. See here, I2, I1 is to 1 should come here, is to 1. Okay, and then what is the next I4? Yeah, you have I4 here. So the only path is I2. So I2 is to 1 because we have I4 support count as the 1. Then when we come to I3, so you have one I3 here and you have one I3 here and you have one I3 here. So three paths you have. So when you come here, you have I2, I1 to I3. So I2, I1, what is the support count here? 2. So I2, I1, I2, I1, the support count of I3 is 2. Then the next path is I3 here. It is passing only through I2 where the support count of I3 is 2. So it is I2. Then this is another path here. It is passing only through I1 here, I1 where the support count of I3 is 2. So I1, 2. Then if you come to I1, you have two I1. We have one I1 here and one I1 here. Where for this you don't have any path to be navigated. Only null is here. So we'll not put this. And then we have a I1 here where it's passing only through I2. The support count of I1 is 4. So I'm putting it as 4 here. Hope everybody understood how we have generated the conditional pattern base. Now let us see the conditional frequent pattern. What is conditional frequent pattern? Let us see the occurrences of each and every item and its support count. So in this problem, we are keeping the minimum support count to be 2. Okay, the minimum support count to be 2. So this is our support count. So now let's see I2, it had occurred once and it had occurred once. So I2, it had occurred twice in this. So I2 is twice. So now when you come to I1 it had occurred once here and then it had occurred once here. So I1 is also 2. I1 is also 2. And now when you come to I3, you don't have I3 here. Here I3 had occurred once. So I3 is 1, so which is not satisfying the minimum support count, so I'm eliminating this. That's why you don't have it here. When you come here to the I4, I2, the base pattern should be I2, I1 to I4, which is 1. So the pattern here is 1. The support count for this pattern here is 1. So I2 had occurred once and then I1 had occurred once. So I2 is 2. Whereas I1 had occurred only once. So it will not support my minimum support count. So I2 is to 2. When you come here, I2 had occurred twice and I2 had occurred twice and yeah, only twice. So I2 is 4 times. When you come to I1, I1 had occurred twice and I1 had occurred twice. So I1 is also 4. And when you come to I2, you have only 1, so I2 is 4. So this is how the conditional FP is actually generated. We will be checking the number of occurrences of each and every item. If it is satisfying the minimum support count 2, we will be considering it. If it is less than minimum support count, we will be eliminating it. Now we have generated the conditional FP, occurrences of every item here. Now frequent pattern generated. So now this is the important part where we are going to find the frequent pattern generated. What happens? So this conditional FP is for I5, this conditional FP is for I4, this conditional FP is for I3, this conditional FP is for I1. So what happens now is I'm going to combine each and every item with its item where it have been reached or navigated. So what happens? I2 into I5. I2 into I5 is to 2. Then I1 is to I5 into 2. Okay. Then what happens? I2 is to I1 is to 5 is also 2. So now see here whether this is correct or not, whether the support counts are correct or not. Now let's see here. Look into this. You have I2, you have I5 is to 2. So what happens? Let us see I2 to I5. I2 to I5 you have here. Okay. So the support count is 1 here and then you have I1 to I1 and then I5. So we have I1 and I5 here. So two occurrences it had occurred. So from I2 you have a I5. From I2 you have a I5 which had occurred once, and then from I2 you also have another I5 which also had occurred once. So that is why the support count here is 2. When you come here, this is I1, I5, 2. So from I1, what happens? You have from I1 you have one I5 here, and again from I1 you have one I5 here. So again the occurrences from I1 to I5 is twice. So that is why the support count is 2, because you have one support count here, one support count here, which is 2. Now what happens? From I2, I1 and then I5. From I2, I1 and then I5. So what happens here? Here also the support count is 2. So I2, I1, I5 and then I2, I1, I5. Here also the support count is 1 1, so this is 2. Okay, then when you come to this I4, I2 into I4 is to 2. What happens here? So we can say that I2, where you have I2 is to I4. I2 is to I4. You have 1 here, and then also you have I2 is to I4. You have 1 here. So two occurrences, 1 and 1. 2 times from I2, I4 has been generated. So it is 1, 1 here, which is I2 is to I4, which is 2. So likewise, when you come to I3, you have I2 and I4. So I2 is to 3. Okay, I2 is to 3, I2 is to 3, and I1 is to 3, I1 is to 3, and I2, I1, and then I3. I2, I1, and then I3, which is 2. Fine. So when you see this, again, the occurrences, the path will be 4 for this, 4 for this, and I2, I1 will be 2, as I explained you already. And when you come to I1, this I2 will be multiplied with I1. So I2, I1, again, I2 to I1, you have the base as 4. So this is how we generate the frequent pattern without generating the candidate key. So when you come here, this part or these are the set of frequent patterns generated. So in our a priori algorithm, we'll be scanning we'll be scanning a database to generate C1. Then we'll make the combination of C2 from L1. Then we'll make the combination of C3 from L2, and each and every time for each and every combination we find the support count. So each and every time we are scanning the databases, where the scanning the database is becoming more. Whereas here, just by navigating the tree, we are finding out the frequent patterns generated. This FP growth pattern is mainly introduced to improvise the a priori algorithm and to reduce the number of scans in the database. I hope everybody understood this. Thank you.